Hey, hi friends, and welcome again to my channel, the Goating Playground. And this is Darshna. And in this video, basically, guys, we will discuss about the one of the asked problem, that is a subtree into the tree. Okay, so basically, in this problem, basically, we have to see ki in our existing tree we have a subtree or not. So basically, we will have two trees. That is, one is a complete tree and one is a subtree. So basically in complete tree we have to check this subtree exists or not. If this is exist, then we have to return true, otherwise we have to return false, guys. So to see this problem, to solve this problem, I already implemented and given a solution for you in my previous video, which is find a same like basically check the same tree, both the tree are same or not. So this is a code of the previous problem, which is I explain you. Okay, so in this, guys, in this video basically we will check this problem. We will see use this solution, guys. Or so because in subtree we also have to check the left every node, and if the subtree is a big, then we have to basically check left and right and even the complete tree. So this solution basically helped me here. So the person and the guys who has not watched my previous video, so I am requesting you, so kindly watch my previous video of same tree. There I basically explain everything, and even I make the stake over there. Even I have there basically I explain step by step everything. Okay, so if you guys see this last video of same tree, then definitely you will get some idea. Meanwhile I'll explain something here also, so that you can get some basic idea. So let's start the problem without any delay. So first of all, we have to change the title. Check subtree is or not. Okay, guys, so this is our problem. So what this basically function is saying here, let me check the function. Okay, let's keep this same because I don't have space on the board. So what this function is saying, so function is basically checking every node from left and right for both the trees. Okay, and if left or right, so for first time we are basically checking the left part, and then we are checking the right part, and then we are basically from the return value we are ending them, and then on the basis of ending value we are basically returning the final value. Okay, so suppose from here for this we get true, and from this we are getting true, then finally true, basically we will get true, finally we will return to 1. If there is not here true, here false, then finally true and false we will return false here. Okay, guys, I hope you understood, you understand this thing. And these are the base condition where if the root is basically null, whatever the value we are passing in a p and q, those are null, then basically these are identical, so we are returning true. If one of them, either p or either q, is null, okay, then in that case this basically these are not identical, so we are returning false. If the value of both of them is not equal, then also we are returning true. If everything is fine, then we are basically going ahead and we are basically checking in a left part, and then we are checking to the right part, and then we are ending the result. Okay, so this is what we have. Okay, so what is basically subtree? So subtree, guys, can be at the left side. So whatever the subtree lies, suppose this is the subtree, so this can be a left side. Okay, or suppose I am having only 3, this is I have to check, this is also one subtree, so this is the right side, and also this can be a in that way. Okay, so this is also we can have in a problem. Okay, so in the same way, so there is 3 basically condition which is basically subtree. Subtree can be complete tree, or subtree can be in a left side, So we have to check at left tree, or subtree can be a right tree. Okay guys, so these three conditions can be our basically problem. So if this is a complete tree, then definitely this solution will be our left tree, then also this will be our solution, and the right tree, this is also our solution. What we have to see, suppose there is a function uh, uh, is subtree means boolean is subtree. This is our function where we are getting p or q from bracket or from anywhere. Okay, and here basically these three conditions we have to check. Okay, if this condition is established, then directly we will return true. Okay guys, if this is we have, if this is we have, on the basis of that we will basically return. And the main thing is that guys, subtree can be at left side, it can be right side, or it can be a complete tree. Okay, so once we get a true from either a left side, or once we get a true either from right side, at the same time we basically have to return a true. Okay, that means we completely find the subtree, or either. So let's start from the complete. Okay, because complete can be a condition. So here we am checking tree boolean, I mean b1, we can consider b1, and here we are calling this function f, and here I'm passing p comma q for root. Okay, if I'm checking here, if b1 is true, then return true. Okay guys, so from this line we will return, and next line of this function will not execute it. And suppose v2 for left, so f p dot left comma q dot left. Okay, this and this, maybe the tree can be of left side, so we have, that's why we are checking left. Okay, so from here, if b2 is true, then return true. Okay, if this condition is not there, then what can be other condition can be, let me write here. Okay, if that can be for right hand side. Okay, so this is we can return, finally return. So here we will use, what we will use, function p dot right comma q dot right. If subtree is not in a complete tree, if subtree is not a left, then subtree can be a right hand side. Okay, or maybe not anywhere. Okay, so q dot right. Okay, so if this is true, or it cannot be true, so finally this will be our solution. So I hope guys you understand this solution. So friends, this problem we discussed into the on basically whiteboard. Now let's implement this the same solution that we discussed on the whiteboard. So here, okay, so first before basically implementation, I just again wanted to explain this problem and just wanted to read out. So basically problem is, given the roots of two binary tree, okay, root and subtree. So there is two root we have given. Okay, so if there is a subtree of root with the same substructure, that means if this subtree has the same structure like a complete tree, I mean the subtree of a complete tree, then basically we have to return true, otherwise we have to return false. And there is one thing, tree could also be considered as a subtree itself. That means the complete tree. So as you can see here, we have a complete root tree. Okay, so in subtree also it can be have this, we have. So if this thing if we have a complete subtree, complete value row nodes of tree same structure with the same structure in a subtree, then we can also consider as a same subtree. Okay, so this is here. So basically we already explained this problem into the white code completely. Here we will implement. So let's start the implementation here. Okay, so to start the implementation, first we have to write a function which basically check is same tree. Okay, so subtree is same or not. So for that we have to write a same tree function. So let's return value for that function is boolean. Okay, is same. The is same tree is same subtree is our function name. Okay guys, and from here we copy this, and this solution I already given in my last video, which is a same tree. Okay, there, okay, same tree problem. So you can also see that problem, the same solution. I have created same tree function there. So base case, let's write the base case. Okay, the first case is if both null, if uh, here I'm making as a p and q as making a short of them. Okay, p belongs to the root and q belongs to the subroot. Okay, p equals to null and q equals to null. So guys, for complete explanation of this problem, you can watch my you can watch my same tree problem, which one is the previous problem of that problem. Okay, there I explain completely. Here I have not completely on a whiteboard also, because with that one I also explained in the previous video. Okay, and other case is a false case. So there, either this value, either p is null or q is null. So p is null, q is not null. Okay, and let it make AND condition, because in both condition we have to return false, or condition, sorry. And let's keep in round bracket. Here p is null, p is not null, q is null. And next condition is, if both is not null, then we have to check the value of both. The p dot value not equals to q dot value. If this is the case, then we have to return, also we have to return uh, false. If from there there is a no condition is matching, then we have to basically go into the left side and right side to check every node. Return. So here basically we will check left side. So let's copy this and call this p dot left comma q dot left. Okay guys, and we have to make, also we have to check a right tree, right hand side, right subtree. So we here you p dot right comma q dot right, q dot right. Okay guys, and once we get the left or right value, we have to evaluate both value true or not. So we have to make it AND condition here. Okay guys, okay. Or we can make it, we can keep this condition into the variable. So here we are keeping is same. Okay, boolean it's same, sorry, not safe. And here we are assigning this value. Let's minimize this. Okay, and this is correct guys, and this we require one more bracket here. Okay, and yeah, correct. So now we return it's save. Okay guys, and the spelling of the return is wrong. Return, okay, that's why it was coming in that way. Okay guys, so as the problem says, the value can be a subtree, can be a complete tree. We can consider it can be in a left side, it can be right side, so we can find a subtree at anywhere. So once we find the subtree, we have to return a true, no matter from where we are getting this. So let's check from root, for root. Okay, so god, for root, so let's call this same function. So here we can see p comma q we can pass, okay, and we can return if we get true. Okay, or we can, for you guys, let me make it like that, root true is root. Okay, in that way I'm trying for you. So if is root true, then return true. Okay guys, and let's copy this and let's check for left subtree. Okay, and here we will check, this will be boolean guys, and the boolean, and here is left, okay, equal, and same here we will check if is left, then return true. So guys, if this is not in a left, this is not in a right, then definitely this is not in a root, this is not in a left, then definitely it can be a right, but cannot be. So let's copy this, and we have to make it left here because we are checking left part. Okay, okay guys, and here will be right subtree. Okay, so directly here we return, this is for right, so p dot right we will do, okay, and q. Now let's run this problem. What is it? Okay, okay, so let's keep this, make it p or q for saving the time, and here we have not written any values, so return true here. So this is run. Okay, now some this is only, let's optimize this problem. Okay, that should I do earlier. Okay, so I just wanted to remove this line and I wanted to use same return value here directly. Okay, and same thing I wanted to use here. Okay, that's fine, not issue. So let's run again. So again, this is working, and now submit now. So guys, I got the problem now. What is the problem with this solution? Is everything working fine? Okay, now this case is failing. Okay, this case is previously also passing. Now why this case is failing? Let's see. Okay, so this is a case basically. Okay, so you can see here there is a no right child. Okay, only a left child, sorry, not a left child, or left subtree, only right subtree is going on completely, but this can be basically made at any position. Okay, so this is the condition. So basically what we have to do here, as this is basically also a subtree. Okay, this output is also a subtree, so we have to check again this left or right subtree by using this is subtree function, because we have to again we have to check all these three condition. It can be possible like complete tree can be whatever left or right. We are basically first let me check this, then I'll let you know. Okay, so basically that can be possible like once we are going to basically use this uh, we are going to find the left subtree, and we are basically finding the tree subtree into the left side. So at this first time we can find as a left subtree of a root, or whatever subtree we are getting, these match same time. Okay, so but it can be possible in a subtree there are also more subtrees, so we have to go again in deep and we have to find where is subtree is basically matching in the left match, and it's also where it's matching in a right subtree side. Okay, so for this condition we have to follow again this step again. So that's why we have to call this subtree again, and let's run again. Okay, now it's run some completely, and let's submit this, and this is also submit now. So I hope guys you understand this problem. Yeah, I just mislead by this condition. I just forget this condition, but yeah, when the code is executed and the one test case is pass basically, sorry, fail, then I recognize like what I'm missing here. And if you like this solution, then kindly subscribe my channel, press the bell icon for more videos. Thank you, bye bye, next video milte hain.